A very good morning, students. Today in Oceanography, we'll be learning about ice in the sea. Sea ice formed as the sea water is frozen in high latitude seas. Besides the sea ice formed by the freezing of the sea water, other floating is introduced to the sea from the nearly land by the great rivers. And in addition to this, icebergs from different types of glaciers reach the sea. It may be pointed out that flowing river ice is not very important. However, it is present in the coastal waters of Siberia and North America. After going through this lesson, you will be able to understand ice, its importance, its types. Ice in the sea is classified into two broad types: the sea ice or the pack ice, which forms directly as a result of freezing of the sea water, and second type, the icebergs, which originate in their place of origin or the source regions on the land. Importance of ice in the sea. Ice in the sea is of great importance in many respects. It's a source rather than a permanent source of navigation. It is in fact the danger of floating of the icebergs to shipping that brought about the formation of ice patrol. Attention may be drawn to the Titanic disaster that occurred in April 1912. This was certainly the worst ever sea tragedy which cost the lives of 1,517 passengers aboard. Following the Titanic disaster, the US Navy began its ice patrol. In 1914, it became an international patrol. In addition, the danger to shipping has been mainly responsible for initiating a very sophisticated system of iceberg warning in the seas around Newfoundland, where the icebergs pose greater danger on account of frequency of dense fogs. The formation of the sea ice renders many seaports and harbors in the high latitude regions unusable. It is worthwhile to keep in mind that the distribution of the sea ice is controlled by climatological processes. Lastly, the pack ice also poses danger to harbors and ports as they cause their freezing, particularly in winter. Sea ice and icebergs dominate ice conditions in the Arctic and the Antarctic, and sometimes they are carried to relatively warmer oceanic regions by oceanic currents. This kind of ice drift prolongs the presence of winter ice on the sea surface in the polar regions into spring and even the summer. Thus, it is of considerable importance for shipping. Formation of the sea ice. In the atmosphere, as we know, the condensation takes place on the hygroscopic nuclei, the microscopically small particles of dust. In the same way, in seawater, ice crystals are formed on crystallization nuclei comprising the smallest possible particles of organic or inorganic origin. Crystallization may occur at an aggregation of a number of molecules which are ground together by change. These molecules also play a significant role in the formation of the ice crystals. In addition to crystallization nuclei, the sea water must necessarily be supercooled. If the purity of water is of greater degree and it is totally undisturbed, then it must be supercooled to a greater degree. Another important point to keep in mind is the fact that the formation of ice releases latent heat of conduction. For a change of water from a liquid to the solid state, heat must be continually removed that should be of greater amount than the latent heat of condensation. In very calm and cold water, the ice crystals so formed are extremely small with a needle-like structure. On the contrary, if the water is in contrast motion, the needle-like structure is replaced by such crystals which look like flat plates with irregular rounded edges. It is well known fact that the freezing point of sea water depends on salinity. At 35 parts per thousand salinity, the freezing is minus 1.9 degrees Celsius. As water freezes at the sea surface, the dissolved solids present in the sea water do not fit into the crystalline structure of the ice, and thus part of the salt content of the water is left behind during the formation of the ice, and thus part of the salt content of the water is left behind during the formation of ice, and as a more or less concentrated salt solution fills the various separating layers between the ice crystals. Remember that the ice crystals consist of pure water. Since ice crystals are separated by the aforesaid salt solution, in the beginning ice is characterized by little solidity. It is, however, interesting to know that the dissolved solids being left behind increase the salinity of the surrounding water. This greater salinity lowers the freezing point of the remaining water that is yet to freeze. The low temperature, high density water that is excluded from the ice has a tendency to sink. This high density sinking cold water is replaced by the warmer and less dense water at the surface. This diffusion process beneath a forming ice layer is perhaps the reason why the crystal plates in seawater are oriented perpendicular to the freezing surface. This type of circulation, as mentioned above, enhances the formation of the sea ice. In this process, freezing is aided by lower salinity and calm water weather is no mixing of winds or currents. As stated earlier, in the beginning of the formation of the sea ice, the ice crystals are needle-like. They are hexagonal in shape. Later on, ice crystals grow in such a larger number that a slush condition is produced. When the slush begins to form a thin sheet of ice on the sea surface, it is broken by the wind stress and the wave action. Now, the thin ice sheet is converted into small disc-like shaped pancakes. As the freezing proceeds further, the pancakes converge and coalesce to form what is called as floes. The individual plates have a diameter of 0.5 to 1 meters. With a maximum of about 3 meters, in calm weather, the pancake ice and the ice slush coalesce to form a solid layer of the so-called young ice, having a greenish blue color and a thickness between 5 to 20 centimeters. Even though the rate of ice formation is closely linked with temperature conditions, it becomes slow as the thickness of the ice increases due to the poor heat conduction of the ice. There is a significant quantity of brine that is trapped during the freezing process. The newly formed ice may have salinity ranging from 4 to 5 parts per thousand. Actually, salinity of the newly formed sea ice depends on the rate of freezing. If the ice forms more rapidly, larger amount of brine will be captured, resulting in higher salinity. However, after some time, the brine will percolate out, resulting through the core structure of the sea ice, and the salinity of the sea ice will decrease accordingly. Classification and terminology of the ice of the sea. The ice in the sea has been classified in different ways according to oceanographers' viewpoints. Similarly, in case of terminology used for different ice forms, there is a lack of uniformity. According to Dryglaski, there are two main forms of the ice based on genetic relationship: shelf ice and the sea ice. Shelf ice represents a traditional stage between the forms of ice found on the land and the ice found occurring at the sea. Shelf ice attains its maximum thickness and extent around the Antarctic. The shelf ice is found along the northern coast of Great Land, which is known as paleocrystalline ice. On the other hand, the Arctic shelf ice formed along the east coast of Greenland has been termed the floating land ice by Wegener. In the sea ice, there occurs a gradual change of ice crystals to ice slush. When the temperatures are low and the weather is calm and clear, ice crystals freeze together and a hard layer of ice about 5 cm thick is formed at the sea surface of the sea. But in windy weather and very low temperature, small sheets of ice are formed with a very rapid growth. Their forms are plate shaped with their margins bulging upwards. This is the well-known pancake ice. In calm weather, pancake ice and the ice slush coalesce together and form a solid layer of what is called the young ice. Its thickness varies between 5 to 20 centimeters. Its color is greenish blue. Further increase in the size produces the sheet ice. When these ice sheets are broken and piled up by pressure, the pack ice forms. Yet another new terminology of ice forms has been used by Mostrad and Zuckerelgel. They have divided sea ice according to age. Winter ice represents only 1 year old ice, which is both soft and plastic. It occurs as ice lumps. On the contrary, polar ice is generally more than 2 years old. It contains little salt and is relatively hard. Under the impact of the pressure, it takes the form of a pack ice. On the basis of the position and movement, Mostrad divides the sea ice into two groups, solid ice and drift ice. Solid ice remains in the same place throughout the winter. It is mostly found in the bays, fjords and other sheltered shallow water. However, occasionally it is broken up and drifts away. The drift ice takes different forms. Its greatest expanse is to be noticed in the drifting ice fields of the polar ice in the Arctic Sea. Physical and chemical properties, the sea ice comprises the salinity, thermal properties and the mechanical properties. But the lack of space does not permit the discussion of these properties of the sea ice. King's classification of ice in the sea. CAM King has divided ice in the sea into two broad types, icebergs originating on the land and the sea ice or pack ice which forms directly by freezing of the sea water. Icebergs pose for great danger to shipping since they reach fairly low latitudes at times. On the other hand, due to the pack ice, the harbors froze up in the winter months. Icebergs. There are two types of icebergs which are characteristic of the northern and the southern hemisphere. The northern icebergs are produced from calving glaciers, while the flat icebergs of the south that are larger in size are derived from the calving of the large blocks from the shelf ice found around some parts of the Antarctic continent. The Antarctic glaciers move rather very slowly, so the true icebergs are smaller in number in that region. But the iceberg formation is most active in Greenland, where there are fast flowing glaciers. The icebergs in the northern hemisphere are only smaller in size, but they are also irregular in shape. The northern glacier derived from such glaciers which are characterized by large number of crevasses and which break into fairly small pieces. On the other hand, the Antarctic icebergs are generally very large and flat topped. Since they are less dense, they float higher in the water. These Antarctic icebergs are sometimes 96 kilometers in length, but most usually are smaller, being less than about 6 kilometers. Most of the icebergs are about half a kilometer long and 30 to 40 meters high above the sea surface. There is a great irregularity in the calving of the Antarctic iceberg. In certain years, the number of icebergs is more than the other. It is to be kept in mind that all the icebergs in the southern hemisphere are produced around the Antarctic continent. They drift much further north than the pack ice. The northern limits in the Atlantic, Pacific and the Indian Oceans are usually 35 degrees south, 50 degrees south and 45 degrees south respectively. In the South Atlantic Ocean, the cold Falkland current drives the icebergs along with it to more northerly limit. Wherever the icebergs float on the pack ice, they move at a greater speed through it. They are generally and greatly influenced by ocean currents, while the movement is largely controlled by the winds. These icebergs are very dangerous to such ships as are trapped in the pack ice lying in the iceberg's path. Remember that since these giant icebergs melt after a long time, they drift to greater distances from the continent than the sea ice or the pack ice. As an exceptional case, small piece of floating ice was seen 26 degree 30 minutes latitude and 25 degree 40 minutes west latitude and longitude on April 13, 1894. In the northern hemisphere, the main sources of the origin of the iceberg are the sea coast of Greenland, Franz Josef Land and Novaya Zemlya. Along the northwest and the southeast coast of Greenland is the most numerous, from which the source regions of the iceberg drift south in the cold Labrador East Greenland current. Iceberg carried southward by the above mentioned cold current merged together, each of the Grand Banks between 43 degree north and 47 degree north latitude. Remember that it is in this zone that there is a dense fog during most of the year, as it is the meeting zone of the cold Labrador current and the warm Gulf Stream current. The tragic loss of the Titanic ship occurred in this zone in 1912. However, since the International Ice Patrol has been operating here, there is a great variation in the number of icebergs from year to year. Besides, the southerly limit of the icebergs also varies greatly. For example, as many as 1,300 icebergs were sighted by the Ice Patrol in 1929, whereas only 11 icebergs were seen in 1924. In those years in which the number of icebergs are normally high, some of these may reach as far as 30° north latitude. The lifespan of the Greenland iceberg is reported to be less than 2 years. The icebergs with a gigantic size of 50 million cubic feet in the Davis Strait decreased to only 6 to 8 million cubic feet at the Grand Banks. Large number of the icebergs appear in this area from the middle of March to the middle of July, with the maximum number arriving in the month of May. The so-called ice islands of the Arctic Sea, with a smooth surface and dimensions measuring 17.5 into 7 kilometers, originate from the ice shelves in the vicinity of the Greenland and the Ellesmere Islands. During the course of their long journey, the original ice at the bottom disappears by melting away, with the result that the ice island finally consists of only fern. Polar ice. Polar ice covers the largest area of the Arctic Sea, including the polar region. Its maximum thickness exceeds 15 meters. However, during the warmer summer months, it starts melting, as a result of which enclosed bodies of water known as polynyas are produced. Remember that the polar ice never disappears completely, but its average thickness in the summer is decreased to about 2 meters. There is a continuous exchange of polar ice as floe ice from the pack ice and renter pack ice in the summer. About 33% of the pack and the polar ice enter the North Atlantic through the East Greenland Current every year. Fast ice. Fast ice develops during the winter season from the shore to the pack ice. It disappears in summer by melting. It is firmly attached to the shore in the winter. Its thickness exceeds 2 meters. Fast ice remains fixed in its position of growth, and its only movement is up and down with the tides. A sheet of fast ice which projects more than 2 meters from the sea level is known as an ice shelf. The limit of the fast ice coincides with a water depth of 20 meters. In places off Siberia, where water is shallow to a great distance from the shore, it extends seaward over 400 kilometers. This is particularly so off the mouth of the rivers Yana and Lena, where additional discharge of water causes low salinity, and hence conditions are favorable for the ice formation. In the southern hemisphere, the entire polar region is covered by continental ice sheet. All the sea ice forming around the continental margins of Antarctica, which is of temporary existence, may be characterized as pack ice. It hardly extends north of 55° south latitude from October to January. It disappears completely except in protected bays, which are very calm. Very strong winds do not allow the formation of a greater accumulation of the pack ice around the Antarctic continent. Summary. The interactions between the atmosphere and the oceans and the interdependence of the atmospheric and oceanic circulation are well known. As a matter of fact, the oceans and the atmosphere can be treated as a single complex system of two coupled fluids. The sea ice, which covers about 23 million kilometer square area of the oceans, exerts great pressure on the air pressure. Even the temperate cyclones shift their paths equatorward in those years which are marked by heavy ice. It is estimated that in the southern and the northern hemisphere, about 32 million kilometer cube and 7 million kilometer cube ice melt each year respectively. As stated earlier, during the process of melting of such huge amount of sea ice, considerable amount of energy is consumed. It results in lowering of the surface temperature of the sea surface. The great variations in the area of ice cover has a far-reaching effect on the pressure system on the climate of the earth. However, the climate itself reflects the sea ice formation and also its areal extent. In this way, sea ice plays a very important and complex part in the atmospheric circulation. The pressures in the polar region being consistently high throughout the year, the prevailing easterly winds blow from these regions to the subpolar low pressure systems. Thank you.